In this second part of my intro to Python, we're continuing on with programming structures. At the end of part 1, we covered the use of the while command, which loops until a test condition is true. We also saw how the use of indentation is used to mark the contents of these commands, and the end of indentation signifies the ending of the command, much like brackets and curly braces and other programming languages. Now we have idle up, and I'm going to advance to the next section, which is called more flow control tools. The if clause in Python is also called an if-then statement. There's additional functionality saying that if this, then do this, else if this, then do something else, then if the third thing is true, then do something else, and then if nothing else works, then do this. Thinking about an if statement in real-world terms will help with structuring in the command. Let's process the example that we see here. It's stating if the variable x is less than 0, then set x equal to 0 and print negative change to 0, which happens to print on the screen. Else, if x is equal to 0, then print 0 to the screen. Else, if x is equal to 1, print single to the screen. And then for everything else, print the word more. Now, if we're setting x to 0 in the first term, wouldn't that make the second term process? And the answer to that is no, because of the way the indentation works. Once the indentation ends, that if condition has fired, and it assumes that it is finished. Nothing else is true. So it simply jumps to the end of the if statement. So processing follows down the if statement, checking to see which one of the conditions is true. And it continues like this until the else statement is reached, or there's a return or a return from indentation. There's a couple of new things shown in this example that I want to run through. The first is at the very top, the raw input command. It shows a message and then takes a response and then assigns that to a variable. It's an input command. Here's a message, input, and then it's setting it equal to x. Let's see what the Python library tells us about that. I'm going to come over to the built-in functions section, and I'm going to go to the raw input command. Reading through, it indicates that the raw input command converts everything to a string. Let's continue to the example. So what the example is doing is it's getting a string from input, converting it into an integer, and then assigning that to x. So we see that in the code. There is the response it gave. Note the trailing space at the end. There's no comma there. So you'll want to segment that off. The example issues 42, and so it starts running through the commands. Is 42 less than 0? No. Is 42 equal to 0? No. Is 42 equal to 1? No. Oh, I hit an else statement. I have to run this. So it sequences down the order of events. The other thing to note is the double equals sign. We know that an equals by itself as an assignment assigns a variable a certain value or string. The conditional comparison is the double equals in Python to determine get a true false on whether or not something is equal to something else, you will use the double equal sign. The other new command here is print. Print is a versatile command. It puts information or data back to the screen. By default, it takes what you want to print with regular strings or variables. As an extra note, you can use a combination of strings and variables by separating them with commas. Note that I've done that here in the idle window. Print the number is an X after I signed X. So it printed the value of the variable and then a space, and I didn't need that trailing space because the comma issues it. So you can combine different types of outputs with a comma in a print command. Next, we have the for statement. For statements are a way to iterate through a list or a string variable. Unlike other programming language, for in Python does not have a native iterative structure. In other words, sequencing through a series of numbers from 1 to 10, for example. For example, the way a for loop works in C++ is, let's see if we can find. There we go. The for in C takes and assigns a variable a beginning number, assigns a condition, and then states how the variable is supposed to increment. As long as that condition is true, it will keep running this and cycle through each one and begins an instance. Python doesn't do that by default. It takes a string or a word, or a list, and then allows you to iterate through the different items inside of that. So this for command reads, for each item in the list words, assign that to the variable W, and then process this. Print the actual word, the item from the list that our variables assigned to, and then give me how long that is. So here we set words to a 3-letter word, a 4-letter word, and a 12-letter word. So the for loop processes through this for each item in here and runs this statement. Says, okay, first item is cat, its length is 3. The next one is window, its length is 6. The next item is demonstrate, and its length is 12. Once the for command has gotten through all the items in the list, it simply ends. The next example, shown here, shows how using slicing is used to present a copy of the list for the for command with the purpose of editing the original list. We see a method for a list here, the insert method. Remember that methods are just functions that operate directly on objects. The insert method takes an index number, and remember that indexes start with 0, and and the item to place into the list. And just as the name of the method implies, an item is inserted to the list at the position indicated. Now, if you want to iterate through a count, like to go through the index numbers in a sequence or a list, then Python supplies the range function. By default, the range function takes a start which is optional, a stop, number, and a step. Let's look for that here. Let's scroll up to the top. Let's go to range. If the step argument is omitted, it defaults to 1, indicating that it's going to step one at a time. The start argument is omitted, it defaults to 0. So we can assign it one number to end at, and just like in slicing, the ending number is not inclusive, so it defaults start to 0. And if we start with a number and then end by that number, again, the ending number is not included. Likewise, here's an example of a range that starts at 0, goes up to 30, and then increments by 5. Note that 30 isn't in that list. Likewise here, going 0 to 10 by 3s. And range allows you to walk through numbers in the negative format. Where might that be useful? Well, remember, we can move through a string or a list from left to right by starting with indexes that start with a -1. Let's go back to our example. And now we see a for loop. In this for loop example for range, we see that range is called with one number, a length of a list. So we have a list set, and then a range is called with one number, a length of a. Now, from the previous session, we know that the length of a list returns the number of items in that list. Let's verify that. Sure enough, length of 5, indicating there are 5 items in the list. So if we issue a command that does this, then we are giving it one number 5. In range, we know if we give it one number, starts at 0 and loops to the end up to that number. Why is that important here? Because indexes start with 0. Which index is the 5th item here? It's an index of 4. 0, 1, 2, 3, 4. So range, and the fact that it is not inclusive of the ending number, is very useful in a for loop for iterating through, I forgot the word in, for I in range of the length of a. Then what are we going to do? We're going to print I, which is the index number, right? And then we're going to call the instance of that list. And so what does that do? That says, well, we're printing the index number, and then we're calling the list with the index number in order to get what it had. Very useful in going through an entire list of things. Other ways to process loops involves the use of break commands and continue commands. Those are ways to basically stop the processing of a for loop or restart the next loop prematurely, depending on if something happened. And you note that these are indicated in the if based on certain conditions. Next is a pass command, and it is strictly a placeholder that does nothing, mainly used for exercises if you want to have somebody fill in extra code, or if you're going to prototype the structure of an entire program. Now, we know that there are built-in functions, but Python allows us to create our own functions. Okay, we know there are built-in functions, but Python allows us to create our own functions. Say we want to iterate and want to do something on a string for items in a list, and rather code that fully, we can place the editing into a function and just call the function into a loop. This makes code a lot easier to read. In the function example, we're going back to the Fibonacci sequencing from the while command in the last session. This time, we set up a function that prints a sequence and hand to it how far it will go. In the event that we need to call the code repeatedly, this is the value of defining our own function. And as always, a colon starts the command. Everything is indented, and the end of indentation signifies the end of the definition or the function. Functions are given with a def command, the name of the command, and then the input parameter. So for this example, this code looks exactly as it did yesterday, where we're setting A and B, we're printing A, resetting A, and letting it run through each time in a while loop. This time, we're using the called number n that's passed to it to be the reference point. So for calling up to 2000, the output goes all the way up to there. Functions also have broader uses. They can print and process inside of them themselves. They can return objects or values as a result, just like built-in functions do.